In this video, we will see examples for IUPAC nomenclature of coordination compounds. Now, before we come to the IUPAC nomenclature, I have written here a table with 4 columns. The first column I have name of the ligand, second column formula, third column charge, and fourth column name of ligand in the complex. Now, cyanide ion, how to write the name in the complex, that last E is replaced with O, so it will be cyanido, or you can also name it as cyano. And you can see I have written the names of ligands with negative charge first, negative ligands. Second is nitrite ion, the name is nitrito. Third is nitrate, nitrato. Hydroxide, hydroxo. Chloride, chlorido. Now, thiocyanate, thiocyaneto. Next, isothiocyanate, isothiocyaneto. Sulfite, sulfito. Next, I have sulfate, sulfato. Thiosulfate, thiosulfato. Carbonate, carbonato. Then last we have oxalate ion, and the name in the complex is oxalato. So the last E of the ligand is replaced with O. Now next I have written examples for neutral ligands, means the charge of the ligand is 0. And examples are methylamine CH3NH2. It is named as methylamine in complex. Second example, ammonia. The name of ammonia is amine, and remember the 2M must be retained. Next, water is named as aqua in complex. Nitric oxide is named as nitrosyl, and nitric oxide is NO. Then carbon monoxide is named as carbonyl. And last we have ethylene diamine denoted by EN, and it is named as ethane 1,2-diamine in the complex. Now next, let us see the examples for IUPAC nomenclature of coordination compounds. Now look at the first example. CONH3 6 times Cl3. Now to write the IUPAC nomenclature, the first step is to find the oxidation number of the central metal atom. So let's calculate the oxidation number of the central atom cobalt, which we don't know, that is written as X. Now the ammonia is the ligand whose charge is equal to 0. Now we have the counter ion as chlorine, chloride, and its charge is -1. So -1 into 3 is -3. So what will be the charge of the complex part? It will be +3. Now let's calculate the oxidation number. How will you calculate the oxidation number? The sum of charges of ligands and X is equal to the charge on complex ion. So let's calculate the oxidation number of cobalt, that is X plus 0 is equal to +3, or X is equal to +3. Now let's find the name of this compound. First we have to write the name of the ligand. Here we have only one ligand, so it is ammonia amine. And there are 6 ammonia molecules, so it is written as hexaamine, hexaamine. And remember, hexa and amine A, both A has to be retained, and amine, double M, also to be retained. Hexaamine. Next is the name of the metal. Here we have cobalt as the central metal atom. When we write the name of central metal atom, we have to check the charge of the complex ion. The complex ion is +3, positive. So you can write the name as such. So how will you write the name of cobalt? It's written as cobalt itself, followed by the oxidation number, that is +3, and it is written in Roman numeral in bracket. Now we have the counter ion, chloride. Though we have Cl3 here, we will not write trichloride. We will not use any prefix before the name of the counter ion. So we will write it as chloride. So this is the IUPAC name of the first compound. Now let's see the second compound, K3FeCN 6 times. Now here the counter ion is potassium, ion central atom. You have to find the oxidation number. Cyanide ion charge is -1. So potassium +1 into 3 +3, charge on complex ion is -3. So let's calculate the oxidation number of ion. X -6 is equal to -3, so X will be equal to +3. Now let's write the IUPAC name. First we will have a counter ion, that is our potassium. No need to write tripotassium because we don't use any prefix before the name of counter ion. So it's just potassium. Now only one ligand and 6 cyanide ions. So hexacyano. Cyanide ion can be written as cyano. Then next is the central atom, that is iron. Now when you write the name of the central atom, you have to check the charge on complex ion. The charge on complex ion here is negative, -3. So it is to be written as 8. So iron, when you write, you will write it as ferrate. So this is ferrate, followed by the oxidation number of iron in Roman numeral and bracket. There is 3. Now the third example is K3FeC2O4 thrice. Again, first find the charge of the complex ion. It is -3. Now you have to find the charge of the or oxidation number of the central atom. This is oxalate ion whose charge is -2. So let's calculate x minus 6, -2 into 3, -6 is equal to -3, or x will be equal to +3. Now let's write the name. The name of the complex is potassium. Now here we have 3 oxalates. So trioxalato. Oxalate is written as oxalato. Now the metal iron. Look at the charge on complex. It is negative. So you will again write it as ferrate. Add the word 8. Ferrate, and the oxidation number is 3. So this is the IUPAC name of third question. Now next we have the fourth example. PTNH3 twice Cl NH2CH3 and counter ion as chloride. First let's find the charge of the complex ion. It is +1. Now platinum, we have to find the oxidation number. Ammonia charge is 0. Chloride ion is -1. This is methylamine whose charge is again 0. So x plus 0 -1 plus 0 is equal to +1, or x will be equal to +2. So let's write the IUPAC name of the compound. Here we have 3 ligands, ammonia, chlorine and methylamine. Now ammonia we have 2. So if there are 3 ligands, you have to write the name of the ligand in alphabetical order, but we don't look at the alphabet of the prefix, we only look at the alphabet of the ligand. So the name of this will be, we have to write ammonia first. So we have 2 ammonia, which means di, and ammonia is named as amine, diamine. Next comes C alphabet, so chlorido. Next methylamine in bracket. Close the bracket. Now we have to write platinum. Now look at the charge on complex ion, it is positive. So you will write the name of the metal as such. So what's the name of the metal? Platinum. Now we have the charge as 2, that is oxidation number, followed by the counter ion, that is chloride. Counter ion, chlorine. You cannot write it as chlorine, write it as chloride. So this is the IUPAC name of fourth example. Now number 5. Number 5 is CO, NH2, CH2, CH2, NH2 thrice. The whole twice, SO4 thrice. Now this group is ethane 1,2-diamine. Now the counter ion is sulfate ion, and you know the charge of sulfate ion is -2. -2 into 3 is -6. Now here to neutralize the charge we have +3. So let's find the oxidation number of cobalt. The charge of ethane 1,2-diamine is 0. So x plus 0 is equal to charge, which is +3. So x will be equal to +3. Now how will you write the name of the compound? Here we have ethane 1,2-diamine thrice. So it is written as tris. We cannot write it as triethane 1,2-diamine. It is written as tris, because that ethane 1,2-diamine contain a numerical or numeral. So let's write tris. So we will start writing the name. Tris in bracket ethane 1,2-diamine. Close the bracket. Now no more ligands. We have the central atom as cobalt. To write the name of central atom, we should check the charge on complex. It is positive. So cobalt is written as such. So cobalt, followed by the oxidation number, which is 3, and the counter ion, that is sulfate. No need to write trisulfate, it is just sulfate. So this is the IUPAC name of the compound. Now next is question number 6. 6 is K3CONO3 6 times. Now let's write the IUPAC name of the compound. Before that we have to find the charge or oxidation number of cobalt. So nitrate ion is -1. So X minus 6. X minus 6 is equal to, here we have plus 1 into 3 plus 3. So here we have the charge as minus 3. So X minus 6 is equal to minus 3. X will be equal to plus 3. Okay. Now let's write the IUPAC name. We have the counter ion potassium. Now we have 6 nitrate ions. So hexanitrato is replaced with O. Now cobaltate, because the charge on complex is negative. So cobaltate, in bracket oxidation number of cobalt, that is 3. So this is the IUPAC name of 6th question. Now next we have 7th question, COEN thrice 3 plus. Here cobalt oxidation number, no counter ion is given. Cobalt oxidation number we don't know, and ethane 1,2-diamine charge is 0, but the charge on complex ion is given. So what is X? X plus 0 will be equal to plus 3. Now again it is ethane 1,2-diamine, so we have to use tris. So what's the IUPAC name of the compound? Tris. In bracket you have to write ethane 1,2-diamine. Close the bracket. Now it is cobalt, because the charge is positive, plus 3. Cobalt 3. You have to write the word ion here because no counter ion is given. The question itself is given the charge of the complex ion. So if in this case you have to write the word ion. Okay. So this is the 7th question. Now question number 8 is TiH2O 6 times 3 plus. H2O, you know, this is also no counter ion. Now H2O charge is equal to 0, and titanium, Ti is titanium, so X will be equal to plus 3. Oxidation number of titanium is plus 3. So let's write the name. Here we have 6. So hexa. Again aqua, remember 2A, hexa A and aqua A. Hexa aqua, titanium. Titanium, because it is 3 plus, positive, and oxidation number is 3. Ion, since no counter ion is given, you have to write the word ion here. Now number 9 is NiCO 4 times nickel. You don't know the oxidation number. CO is carbon monoxide, charge is 0, and here since no charge is given for the complex, it means the charge is equal to 0. So what will be the oxidation number of nickel? X will be equal to 0. Now let's write the IUPAC name. CO is named as carbonyl, and we have 4 CO. So it is tetracarbonyl. Now charge is 0 means nickel is written as such, nickel. In bracket oxidation number of nickel we got as 0. Now the last question, that is question number 10. PTNH3 twice ClNO2. Now here we have platinum, we don't know the oxidation number, ammonia 0, chloride ion -1, nitrite ion we have charge -1, whereas no counter ion is given, which means the charge, this is a neutral molecule or neutral compound, and the complex ion charge is also equal to 0. Let's calculate the oxidation number of platinum in this. X plus 0 minus 1 is equal to 0, or X will be equal to plus 2. Now let's write the IUPAC name. We have ammonia, chlorine, nitrito or nitrite group. So ammonia will come first, and we have 2 ammonia, which means diamine. Then chlorido. Now NO2 is a ambidentate ligand, so we have to show the point of linkage, which atom is linked. Now it is written NO2, So here the atom, donor atom is nitrogen, which means how will you write chlorido? Now nitrite 2, it is nitrite ion. So when you write the name, it will be nitrito. E is replaced with O. Hyphen N hyphen. That hyphen N hyphen. This shows that the linkage is through nitrogen. Hyphen. Now the name of the metal atom, that is platinum, and since it is neutral, you can write platinum as such. N platinum in bracket 2. Now here you need not write the word ion because it's a neutral compound. Okay, so this is the name of 10th question. Now next I have written a back question on the board, that is 9.24. Write down the oxidation state, IUPAC and coordination number of the following compounds. Okay, so let's find out. The first question is KCrH2O twice, C2O4 twice, 3H2O. Now here we have K as counter ion, H2O is named as hydrate. Now we have the ligands as water and oxalate ion. First let's find the charge on complex ion. Potassium is +1, so this is -1. Now oxidation number of chromium, H2O charge is 0, oxalate ion charge is -2. So we have the oxidation number as X plus 0 minus 4 is equal to -1 or X is equal to +3. So the question is to find the oxidation number. We got the oxidation number of the central atom, that is +3. Now let's write the IUPAC name of the compound. To write the IUPAC name, we have potassium as the counter ion, so start with potassium. Now next we have two ligands, aqua and oxalato. Aqua will come first, so diaqua. Now we have dioxalato. Now next we have chromium, but the charge on the complex is negative, so chromium should be written as chromate. And we have oxidation number as 3, chromate 3. Now 3H2O is written as hydrate. Now you will not write trihydrate, though there are 3H2O, you will just write it as hydrate. Okay. Now there is one more question, that you have to find the coordination number. What do you mean by coordination number? The total number of ligands present. That is the coordination number. Now look at here. Here we have 2 H2O and 2 oxalate ion. We know that oxalate ion is a didentate ligand. So didentate ligand we have to multiply with 2 to find the coordination number. So what will be the coordination number of chromium in this? Coordination number will be equal to 2 into 2, 4. 4 plus this water we have 2. So coordination number will be equal to 6. From where did this 4 come? 4 is from oxalate ion. Though we have only 2 oxalate ion, 2 into 2 because it's a didentate ligand. So 2 into 2 plus 2. That is from H2O we get coordination number as equal to 6. Now the next question is, second question, CONH3 5 times Cl, Cl2. Here let's find the charge of complex ion +2. Let's find the oxidation state. X plus 0 minus 1 is equal to +2, or X will be equal to +3. So here the oxidation number of cobalt is +3. Now let's write the coordination number. What is the coordination number of central atom here? 5 plus 1 is again 6. Coordination number is again 6. Now let's write the IUPAC name. Here we have amine and chlorido. Amine will come first and we have 5. So pentaamine. Then chlorido. We will write cobalt because the charge is positive, and the oxidation number is 3, and we have chloride as the counter ion. So this is the name of the compound. Now the third question is CrCl3 Py thrice. Py stands for pyridine. and its charge is again equal to 0. Now here you can see the coordination compound, the complex is also neutral. Now we have to find the oxidation number of chromium. So let's calculate. X minus 3 plus 0 is equal to 0, or X will be equal to plus 3. So the oxidation number of chromium is plus 3. Now let's find the coordination number. What is the coordination number? Total number of ligands. Chlorine we have 3, pyridine also 3. So 3 plus 3 is equal to 6. Now let's write the IUPAC name of the compound. We have chlorido and pyridine. So C will come first, and I am going to write the IUPAC name. It is trichlorido, tripyridine. There are 3 pyridine. Pyridine is written as pyridine itself. Tripyridine, chromium, because it's a neutral compound, and the oxidation number is 3. No need to write ion because this compound is neutral. Now next is example number 4. CsFeCl4. Cs is cesium. Cesium is in first group, so its charge is plus 1. Complex ion charge is minus 1. Now let's find the charge of central atom, iron. So X minus 4 is equal to minus 1. X will be equal to plus 3. Now let's write the coordination number of this compound, iron. Coordination number, here we have only one ligand, that is chlorine, and we have 4 chlorine, means coordination number is equal to 4. Now let's write the name. First we have cesium. Cesium. Now tetrachlorido. Now it is ferrate because minus 1 is the charge of complex ion. So ferrate 3. This is the compound. Now the last question is K4MnCN 6 times. Here let's find the charge K4. This will be minus 4. Now manganese, Mn is manganese. Let's find the oxidation number. X minus 6 is equal to minus 4, so X will be equal to plus 2. Now let's write the IUPAC name. We have potassium, hexacyano. Now manganese is minus 4. Complex ion is negative. So instead of manganese, you will write manganate. M-A-N-G-A-N-A-T-E. Manganate. Then the charge, that is 2. So this is the IUPAC name of this compound. And what is the coordination number of manganese in this? Coordination number is 6, because we have 6 cyanide ion as the ligand. So this is how we write the IUPAC nomenclature of coordination compounds. Thank you.